Good day, this is Jim Pytel from Columbia Gorge Community College, Renewable Energy Technology Program, EET 121 Digital. Today we're going to discuss programmable logic devices. Okay, let's talk about array logic first. Array logic is just like any other array, kind of rows and columns. And what I've drawn here is just a super simple AND array. I haven't drawn the lines here, but if you could imagine these vertical, I haven't drawn the horizontal lines connecting the AND gates, but if you could imagine these vertical lines representing buses, whereby signal A is on the left line, not A is there, B is on the third line, not B is there, and they're running up and down. And now these AND gates have wires that run left to right that look like this. But they're not connected. If you look at them from the side, let's just pretend the horizontal ones are above the vertical ones. And they would look like this. Where this is our gates connecting the line I've drawn right here is the ones connecting the AND gate, and let's pretend this is what an AND gate looks like from the side. And these are our vertical buses, A bar, or not A, B, not B. Okay, so they're really just floating there doing nothing. But now check this out. There's these things called fusible links. What you can do is link these sections. So each AND gate can get a connection to the data structures, the data lines of A, not A, B, and not B. So how you do that is thinking vertically, put a connection from the vertical, the vertical to the horizontal. So let's talk about this gate right here. I'm going to call this one, let's do U1, U2, U3. And for the output of U3, we want A and not B. So what you do is put a drill in there for A and one for not B. So remember, not A and not B are not connected there. So what you get here on the output is A and not B. Pretty cool, huh? So using this here, using this array, you can create any logic function that you wish. But now, all those things I just said right there, they're not really this way. What you have is this array of basically these programmable links. They're fuses. If you can imagine an array looking like this, where these little wiggly lines are fuses connecting every single input. Here's our inputs right here. See every single output to every single AND gate in there. So that's when you open up the package, that's what your programmable logic, that's what your array is going to look like. In this case, it's an AND array because it's all AND gates. They're all going to be connected. So how do you use this thing? Well, what you do is you start blowing fuses. So for example, we want this one to be A and B. We want this one to be A and not B. And we want this one to be not A and B. Which fuses do we blow? Well, you blow the ones that you don't want. And it would look like this. So for the first one, it's just A that's remaining and B that's remaining, so it's A and B. Second one would look like this. There you go, A and not B. They're the only ones remaining connected through those fuses. Third one would look like this, where not A and B are the only ones remaining. Not A and B are remaining. So those are programmable links. Think of them as fuses that can be blown. You're going to get them with all a bunch of fuses, and through the means of the programming that you have for your programmable logic device, you can blow those fuses, and the only ones that remain are the valid logic functions. So what was this? This was an AND array. What is an OR array? Well, same thing, except it's a bunch of ORs down the side. Okay, let's talk about how some of these guys are put together in some of the more common programmable logic devices. First of our simple programmable logic devices is the PROM, the Programmable Read-Only Memory. It's got a bunch of inputs that come into a fixed AND array, and then you have a programmable OR array, and then you've got your outputs. They all kind of take up this form where it's one array and then the next array with the inputs on one side, outputs on the other. The next device is our PLA, Programmable Logic Array. Whereas the PROM had the fixed AND and a programmable OR, the PLA has a programmable and a programmable OR, giving you a little bit more flexibility. The next device is our PAL, our Programmable Array Logic, which has a programmable and a fixed OR. If you could think about it, it's the opposite of our programmable read-only memory, which had a fixed and a programmable OR. The PLA is the Programmable Logic Array, which has both programmable, and our Programmable Array Logic, which is a programmable and a fixed OR. The final device, which you guys are going to probably use a lot, is our generic array logic, which looks like this. And the key thing with a generic array logic is this keyword there. It's a reprogrammable AND array with a fixed OR. This is the one you're going to probably use the most, especially in labs. Basically, it's reprogrammable. You can do it again and again and again, because all these other guys up here, you know, that's one time only. You say, okay, this is what I want, and bang, you blow those fuses. You're not going to put them back together. This guy, you can reprogram it as many times as you want to. Okay, let's finish chapter 3 right here. If I could have you read through section 310 for VHDL. It's a super easy introduction to VHL, kind of finally putting together what the heck is an entity and an architecture, just using some basic programming language. We're not going to be worried about as far as the test on it, but I want you guys to take a look at how is VHDL used. And what they do is just a simple declaration of an AND gate. All right, and we are going to move on to chapter 4.